Hi everyone, today we are talking about gravitation. Gravitation is the force that you and I probably we have the closest work in relationship with, but it's not only what sticks everything to the ground and make it fall down, but explains how stars and galaxies forms and describe how they can die. But even if we can't watch them in action, gravitation is more complicated than it appears.
Generally, I think of gravitation in two ways. The way that Isaac Newton described it and the way that Albert Einstein described it. In the classical Newtonian terms, gravitation is the attraction of everything in the universe that has mass to everything else in the universe that has mass. And it is universal, from the tiniest molecules to the galaxies. It goes with everything. But the strength of this attraction depends on the object masses and the distance between them. The more massive an object, the greater the gravitation force exerts on another. And the forces decreases rapidly the farther apart the two objects are. The force of gravitation is proportional to the product of the two objects' masses and inversely proportional to the square of the distance between them. But for Mercury's orbit, travel with it is what the point the closest to the Sun, its perihelion, isn't where Newton's law predicts, and that will be explained after by Albert Einstein. But it's still his rules universal and correct. Albert Einstein, he entered the term space-time like a fabric of universe, and with his theory of general relativity basically said that objects that either have mass or energy distort that fabric. In the case of Mercury, the closest we get to the Sun, the more the Sun's huge mass curves space-time, what effectively caused that point of perihelion to move. Einstein discovered that gravitation can also influence massless and energetic, like light. If the force strong enough frustrates the observer that light bends around really massive planets and stars. And his general relativity predicts correctly distorted space-time. A compact enough mass can so much that light can escape it, and that is a black hole. Like we know, for each fundamental force there is a particle, a force carrier, essential converse that force between bodies. Gravitation is described being carried by a massless particle called gravitons. But unlike other force carriers like pions and gluons, gravitons are theoretical. They have never been detected and they are predicted to be essential observable. We only get to see their handiwork, and that is what we call gravitation. Thank you for watching, and I hope that you like the video.